Okay, I'm just going to go through momentum very quickly. So, momentum is something an object has because of its mass. Alright, and we define momentum as the mass of an object times its velocity. So mass times velocity. And we often give momentum the letter P. So P is equal to mv. Now, momentum itself has the units kilograms meters per second, and obviously mass is kilograms, and velocity here is meters per second, which is where it comes from, because kilograms times meters per second, you get kilogram meters per second. So quite simply, say we had a truck. Now my truck here, pretty heavy, mass 15,000 kilograms, and for the time being its velocity is 0. So what's its momentum? Well, simply we know that when an object is not moving, it doesn't have any momentum, so its momentum is 0. So when an object is not moving, its momentum is 0. Okay, so say now it gets going, and let's give it some more speed. So let's say same truck, this time it's doing, I don't know, 20 meters per second. Well, its momentum this time, P, is going to be its mass, 1500 times its velocity, so 1500 times 20. Therefore its momentum is simply 30, 1, 2, 3, 4 zeros, so 1, 2, 3, 4, so 300,000 kilogram meters per second. So what happens if we have a collision between two trucks? Say one of them is moving and one of them is not moving. So again, if we grab our truck here, move it down here, okay, and we paste this one. So they collide, so the one moving hits the one that's not moving. So they both have a mass 1500, and this one is obviously its velocity is 0. Oh, sorry, this one its velocity is 20, and this one over here its velocity is 0. Second, and I'll again put mass is 1500 kilograms. And we may be asked to say, what is the velocity of the two when they collide and stick? So often they'll say they'll stick together and move along together. So what is the velocity of both of them together? Well, you need to set this out. So you need to say the momentum before is equal to momentum after. The momentum before is pretty simple to work out. This one is the only one that has momentum because that one's not moving. So the momentum before is simply 300,000 kilogram meters per second. The momentum after is going to be the mass of both of them together times their combined velocity, which is what we want to find. So the mass of them together is simply 1500 plus 1500 times by the velocity we want to find, so v. Now, if I add them together, so again we have 300,000 kilogram meters per second is equal to 30,000 v. When I move this over here, we simply divide. So we don't add. Okay, doesn't like that. Let's try that again. So 300,000 divided by the 30,000 is going to give me my velocity over here. Therefore, my velocity is simply, let's knock these zeros off, 1, 2, 3, 3 gone, that one can go, that one can go. 30 divided by 3 is simply 10 meters per second, and that's our velocity. Then it might say there is a collision, or during the collision time is 0.2 of a second. What is the force exerted? Well, this is another equation you need to know. And force is simply the change in momentum divided by the time taken. And we know my change in momentum, the only one that had momentum at the start of the collision was this one here. So my momentum was actually the 300,000, because that comes from 1500 kilograms times 20 meters per second. So 300,000 kilogram meters per second divided by 0.2 seconds. Now if I'm dividing by 0.2, it's going to make it bigger. Let me just put that in my calculator. 0, 0, 0 divided by 0.2, and as you can see here, it's 1 million. So force is 1,500,000 newtons. Alright, and this is a really important equation you need to remember. I'm not going to go over any example questions for this because I've been over some already, but if you need me to, just ask me during the week. Okay, great. Thanks a lot.